Hello everyone. My name is Shyam Prasad, and I am here to talk about getting the most out of Azure Premium Files when you're working on a Linux environment. So let's get started. A brief background about me. So I come from enterprise file system and storage background. So I have been working on enterprise file system and storage for most part of my career. I am now working as a developer in the Azure Files team in Microsoft, and my primary area of focus in the Azure Files team is to ensure that the Linux workloads have good experience. And as a part of this, over the last 2 to 3 years, I have contributed good number of changes to the Linux SMB project. A brief legal statement. So this work represents the views of the author and does not necessarily reflect the views of Microsoft Corporation. Linux is a registered trademark of Linus Torvalds, and other company, product, and service names that may come up in these slides are trademarks or service marks of others. Okay, let's a high-level overview of what you're going to cover today. We're going to start by going into the basics of what is SMB, what is SMB multi-channel, and then we are going to introduce the Azure Files service for people who may not be aware, and then the Azure Files premium offering called Azure Premium Files, and how SMB multi-channel can be used with the premium files. And then we go into how multi-channel can be SMB multi-channel can be accessed using the Linux client. A bit about the recent changes that have happened on the Linux SMB kernel client around the multi-channel area. And then we'll go over some performance benchmark numbers while using multi-channel. And then list out some of the future improvements that are to be made in this area. Okay, let's get started with what is SMB. SMB is an acronym for Server Message Block. It is a network file sharing protocol where a client server model is used in order to form the file system. It has evolved over several versions over the last couple of decades, and the latest version being SMB 3.1.1. So SMB has called these versions as dialects and allows a client and a server to negotiate for the best possible dialect whenever it can. Okay, what is SMB multi-channel? So remember the dialects that we spoke about. So SMB 3.1.1 as a dialect came with a bunch of the new features, and SMB multi-channel is one such feature. So what SMB multi-channel is it enables the aggregation of the network bandwidth and also allows for network fault tolerance. So the way it does this is by setting up multiple connections or channels between the client and the server. So it contributes to, so as a result of these multiple channels, it contributes to substantial increase in the performance. So one key area. So there are different ways in which the SME multi-channel works, particularly when you have multiple adapters. But even with a single adapter, and when you have the server supporting receive side scaling, a feature that allows the performance to scale when multiple connections are made to the same adapter. Multi-channel can be used in this scenario as well. An introduction to the Azure File service. what it essentially is, fully managed file share in the cloud. This is a cloud, and then it is a cloud service that accesses that can be accessed over SMB, NFS, or REST protocols. Again, these are popular file sharing protocols, more so SMB and NFS than REST. REST is a HTTP based protocol which was primarily used for object stores, but Azure also supports file store access using REST protocols. And then what it allows is for shared access to files. So you can have multiple clients that are connected to the same share, and then accessing the files all at the same time. And then what Azure Files offers is the cloud resiliency. So when I say cloud resiliency, Azure, so for the SMB or NFS file access, it can be done using other servers as well. But where Azure Files has a difference is that it is the server code is designed ground up for the cloud. It is designed keeping in mind that it will operate on a public cloud. And then another side effect of using this common protocols like SMB and NFS is that it supports for a wide variety of operating systems, access to a wide variety of operating systems. Particularly since both SMB and NFS have support on popular operating systems like Windows, Linux, Mac OS, and etc. etc. So Azure Premium Files is a premium offering in Azure Files. So what's the difference with the standard offering is that the premium offering is optimized to deliver consistent performance. So this works on a provision model where the user is allowed to provision the size of the file shares, and accordingly the performance of the file share also scales. And again, this means that you have faster storage, you have faster network that is used on the cloud for these particularly these file shares. So SMB Multichannel also supports Azure Premium Files also supports SMB Multichannel over SMB 311. So you need to ensure that SMB 311 is used by the client, and the client also supports multi-channel in order to connect to Azure Premium Files using multi-channel. Azure Premium Files relies on RSS to support multi-channel, in the sense that it uses it has interfaces that support RSS in order to support multi-channel. The way you can enable multi-channel is that once you've created a storage account, like the screenshot shows in the portal, in the Azure portal, you have a place where you can create the file shares, and in the same page you have an option to enable or disable the SMB multi-channel on top. So you need to enable the multi-channel, and since that point you can create file shares which can all be accessed using SMB multi-channel. Okay, so now say your workload primarily consists of a Linux environment. So you can still connect to shares on Azure Premium Files using SMB multi-channel. One caution here is that it has to be since the 5.8 kernel. So 5.8 kernel is where the SMB multi-channel was introduced in the SMB client. Although it is advisable to use as newer kernel as possible when you're using the multi-channel feature. Although like newer critical fixes that have gone to newer kernels have been backported into the older kernels up to the 5.8. So 5.8 is a bare minimum if you want to use the multi-channel feature on the Linux SMB client. So a big thanks to Aurelian Aptel for having made major code contributions in the Linux SMB client to enable multi-channel. So the way to use multi-channel on a Linux SMB client is using the mount option called multi-channel, or you can also specify the maximum number of channels for a particular mount point or a share using the max channel options. So what this mount option does is that it establishes up to n connection, n being the max channels that was supplied, and if nothing was supplied, the default I think the default is 4 channels. So it establishes up to n connections to the server using the IP addresses that are returned by the server. So the way multi-channel works is that the client can query the server for the different interfaces that it has. So in case of other servers that have multiple interfaces, it would return the different interfaces and the speeds that it supports. Azure Premium Files on the other hand will just return a single interface with the single IP address. But this IP address will be a virtual IP address, so it does not mean that it will all go to the same front end for the server. Since this is a cloud solution, each of these channels can be set up into different front ends, even if the virtual IP remains the same. And then, so once the connections are set up, when multiple connections are set up with each connection or hosting a channel, you have a common SMB session that is set up on top of this, and then you have the files being accessed, so all the server communications from the client will be spread across each of these channels. So right now it is a round robin mechanism to spread across the communications to the server. This could change in the future. Okay, so once you have used the mount option and mounted a file share, how do you ensure that multiple channels are actually being used? So one of the ways to check this is using a procfs CIFS debug data, which actually gives a number of other information that like developers can use in order to troubleshoot and debug problems. However, one of those information is the servers that the client connects to, the SMB sessions that are set up, and if there are any extra channels. So what you can see in the screen there is the primary server which was connected to in order to mount the share, and then the SMB sessions that are operating on top of it. So we have one SMB session here with the 3 extra channels. So which means max. So in this case, max channels was specified as 4, and so you have 4 different channels that are being used. One is a primary connection, which was indicated by number 1 there, and then 3 extra channels which come up under the session below. So this is how SMB multi-channel is in itself designed in the SMB protocol. So you will have a primary connection, and then you will set up a session on top of it, and then for each of the extra channels you will bind to an existing session. So which is why it makes sense to display the debug data in this way, which is have one channel, one primary channel, and then all the secondary channels come up under the sessions, under each of the sessions. And then debug data also displays the number of server interfaces that are returned to the client by the server with the query interfaces call. So in this case, as you can see, this is an Azure premium file share that I'm connected to, and it just returns a single interface. But if you can see there, it mentions that the capabilities of this interface is RSS, which means that it supports RSS, and you can have multiple connections to the same interface, and the performance will still scale. Okay, so that's about how the Linux SMB multi-channel was there. I mean, you can use it's as simple as that. You just mount the file share using multi-channel, and you are good to go. And you have a number of multi-channels. You have number of channels that are set up on which all the server communication will be distributed and will give you scaling in terms of performance. So recently there have been some changes that have happened to the Linux multi-channel, particularly with respect to the reconnect scenario of multi-channel. So before multi-channel came up, you had the reconnect scenario for considering only the single channel. But when you try to reconnect to multiple channels at the same time, there was what used to happen is that essentially it would for momentarily convert to a single channel again until all the channels are reconnected. So this was fixed fixed recently, and what this fix allows for multiple channels to reconnect in parallel. And also there have been changes in the kernel client, SMB client, for the overall improvement in the reconnect code. And many of these fixes have also been backported to older kernels, and backporting is still being done selectively depending on how critical the fixes are. Then you also have the locking improvements that have happened. So there has been performance analysis that was done recently, and this has like we have found a few places where locking was happening at a very high level, and this was causing a bit of serialization when multi-channel was used. So these changes were also done, and that has given even further improvement in performance when using multi-channel. So again, how do the numbers stack up when using multi-channels? So as you can see here, so these are the numbers from a benchmark that I have run. One of the benchmarks, and this benchmark is a 16 KB random write asynchronous IO workload using libIO, and FIO was used in order to generate this workload. So I had a premium file share created on Azure for this purpose, and it was provisioned for 32 TB. And then the client that was used was an Azure VM standard D4AS V5, which is nothing but 4 vCPUs and 16 GB RAM. And Ubuntu 20.04 running the 5.13 kernel was used in this case. And as you can see on the left side, I have the IOPS, which basically scales depending on a number of channels. So you have the IOPS for 1 channel, 2 channel, 3 channel, and 4 channel there. So for in each case, you will see that the performance keeps growing pretty much linearly when you use more and more channels. Also, as expected, the average latency goes down as and when you increase the number of channels. So future improvements with respect to the Linux multi-channel. One is that one of the improvements that we noticed while doing this performance analysis recently is that uh, Azure can, since it's a cloud-based solution, and you can have these virtual IPs that are going to different servers, and you also have like you could also have throttling happening at various levels. The uh, the request consumption on each of the channels can happen at different speeds. So as a result, what is going to happen is that this round robin strategy for spreading the requests across the channels may not be, it may be suboptimal. So one of the improvements that we have identified but not yet worked on is to improve the channel allocation strategy for the requests. Next is that we've also identified a few logs at a higher level. By breaking down these logs again further into fine-grained logs, you could have better scaling in terms of performance with multi-channel. Again, this is something that is theoretical and uh, needs to be tried out, and then some performance benchmarking needs to be done. Also, so far the benchmarking that we used for the perf analysis was FIO. I tried using IO Uring with FIO in order to perform the benchmarks, and the latest FIO that is available on Ubuntu seems to be failing with IO Uring for some reason. So that is something that is still pending, and we are hoping that IO Uring gives further improvement in the performance more than the libIO does. And then for the DFS scenario, so DFS is a scenario that SMB supports, where you can have multiple file shares that are spread across different servers stitched together to form a single share tree, if you may call it. And currently at the moment, the DFS scenario multi-channel is needs some changes in the particularly for the reconnect in reconnect cases where the client wants to reconnect to the server. So today it is suboptimal for the DFS scenario, and that needs to be worked on. And then another case to support is that going forward. So today you have multi-channel that can be accessed using mount option only. If you don't specify this mount option, the default is to fall back to a single channel. So in future, we are looking to support multi-channel and dynamically change the number of channels whenever it is possible. This is not something that we support today in Linux, but this is something that we have in mind going forward as well. So as a reference, you can refer to the different links provided here. The first two are from the Microsoft documentation on Azure Files and Azure File SMB Multichannel. The third one is a link to the Linux SIFs project, the Linux SMB kernel client, which you can find various information like the mailing list and things like that there. So if you have to try out SMB multi-channel and you're seeing issues with it, you can report it to the mailing list also provided there in the Linux in that link, the Linux SIFs mailing list. Also, if you do come across some issues with the Azure premium files, you can again always go to Microsoft support and list out the issue there. So thank you. This was a brief introduction to the Linux SMB multi-channel that the Linux SMB client supports today. So thank you.